Hello and hello everyone and welcome to your lesson of physics. In this video lesson, we're going to solve a worksheet, a complete extended worksheet from the section of Newtonian Mechanics. Right? Newtonian Mechanics is the second section of your physics course, and it consists of the chapters like kinematics, dynamics, mass weight density, turning effect of force, pressure, and elastic deformation. So I have like selected and chosen questions from pretty much all the chapters from this section in such a way that we cover most of the content from this section. So let's start with it. Here we have the first question, which is from the chapters of mass weight density and turning effect of force. Question number 1. A glass beaker has a mass of 50 grams. Alright, soon as we get some information, let's write it down, let's highlight it because it might be used. So mass is given as 100 grams. This is your mass. The density, a liquid of density is 1.8 grams per cubic meters. Okay, density of liquid is represented. Let's represent it with D. Is poured into the beaker until it reaches the volume of 200 cubic centimeters mark. So this is your volume. How do I know that? I know it straight away from the unit, because cubic centimeters is the unit of volume. Calculate the total mass of the beaker and its content. All right. So mass of the beaker plus mass of content. This is what we need to calculate. Mass of beaker plus mass of content. So what is the mass of the beaker? Well, the mass of the beaker is given straight away 50 grams. All right, this is the mass of the beaker plus. Now, what is the mass of the content? Well, the mass of the content is not given straight away, but the density of that content and the volume of that content is given. So we can apply the formula density equals mass over volume, and that gives us mass equals density times volume. And the volume times density would be 1.8. All right, 1.8 we get it from here, and 200 cubic centimeter we get it from here. So 1.8 times 200, 1.8 times 200, 360 grams. Okay, so 360 grams is the mass of the content. Now, what is the total mass? Okay, because you need to actually calculate the total mass. So the total mass would be the sum of these two, which in that case would be 360 plus 50 for 10 grams. Or if you want to write in kilograms, that would be 0.41 kilogram. All right, you can write in grams, either in grams or in kilograms. All right, on to the next part. It says the center of the mass of the meter rule is at 50 centimeter mark, and that makes sense if you have a meter rule which would be 1 meter long, or you can say 100 centimeter long. So the center of mass has to be someplace at 50 centimeter. All right, now the question you state what is meant by the center of mass. All right, so generic answer for this one, every time you're asked this definition you have to write it that way. The region or the point the whole mass of the object appears to be concentrated. All right, on to the next one, part two. The meter rule is placed on a pivot. The tip of the pivot is under the 80 centimeter mark on the rule. The beaker with its content is placed at the position. All right, whatever they have written, we can see it from the diagram as well, which explains everything. And by the way, the questions that I've chosen for today's lesson, these are like the most recent question. Like if we talk about this question, it is from 2021 uh, October November session. So these are like the most recent questions from the most recent past papers. All right, we need to find the mass of the meter rule. This is a question. Calculate the mass of the meter rule. This is what needs to be calculated. Well, first of all, there are a lot of things that you need to consider here. The question of the 3 marks, but there are a lot of things that you need to consider here before you get to the right answer. First of all, the mass of the meter rule will exert force downward at this point, which we call weight. So the mass of the meter rule would also be at this point. You can call it m1. All right. Now, what is the distance of this point from the pivot? The distance of this point from the pivot is 80 minus 50. All right, basically this is your starting point and pivot is your end point. Now what is the difference between 50 and 80? It is 30 centimeter. So I can write the distance d1 equals 30 centimeter. All right, now on the other side of the pivot, what is the mass of this content, the beaker and its uh, content? We calculated in the previous part, it was 0.41 kilograms. All right, let's use in grams. It was m2, it was 410 grams. 410 grams was the mass. Now the most tricky part would be, what is the distance of the center of the beaker from the pivot? I repeat, what is the distance of the center of the pivot oh sorry, of the center of the beaker from the pivot. Well, first of all, the center of the beaker is at a distance of, it starts from 84, ends at 92. So the center of the beaker would be the average of 84 and 92, which is 88. So I can say that the center of the beaker is at the point 88. Now, what is the distance between the center of the beaker and the pivot? It is this 88 minus 80, which would be 8 centimeter. So D2, you can write here, equals to 8 centimeter. All right, now we'll be applying the formula because we need to find mass m1. The standard formula is basically F1 into D1. The principle of moment says F1 into D1 equals F2 times D2. But if the mass is given, you can straight away write in terms of for mass as well, like M1 times D1 equals M2 times D2. How can you write in terms of mass? Because force in that case equals to weight, and weight further equals to mg. So it would be mg on left side, mg on right side, m1g on left side, m2g on right side. Then g from left side, g from the right side would be cancelled out, and you can eventually write the formula m1 into d1 equals m2 into d2. Now let us insert all the values. M1 is unknown. Let us just highlight this one. This is the unknown. All right, this is the unknown thing. Just write it there as it is. Let it be written here as it is. M1 times, all right, D1 was 30. From here goes M2, 410 from there, times D2, 8 centimeter from there. So then you do the calculation, it would be 410 times 8 divided by 30, and then you simply hit it on the calculator. It would be 410 times 8 divided by 30. That gives you 109.3 something grams, because the mass that we used previously was also in grams, so the answer is in grams. And we see that, yeah, so you can like round it off to 110 grams. So that is the answer for this one. Let's move on to the next part. And here we have this question. All right, once again, this is the latest question. It is from the section B of your paper, October, November 2021. I'm not sure if that was from paper 2-1 or paper 2-2. Was from one of those, maybe from paper 1-2-1 or maybe from paper 2-2. But it is the most recent question that you have from kinematics and dynamics. So let's take a look at that. First of all, take a good look at the graph. Whenever you take a look at the graph, make sure you read the label of the axis. It's not a speed time graph, it's a distance time graph. All right. It's a distance time graph, not a speed time graph. So for distance time graph and speed time graph, a same shape would represent different thing. So you have to be careful with it. You need to read it properly, what kind of graph that is. Let's read the question and then we revert back to the graph. Describe how the motion of the bus between 0 and 10 seconds differ from its motion between 35 and 40 seconds. So 0 to 10 second and 35 to 40 second. These are two stages given. 0 to 10 second and then from 35 to 40 second, right? What is the difference between the motion? What is the difference between the motion? This is what you need to answer. So if I am to highlight the portion 0 to 10 second, it is this portion. All right, this is a portion from 0 to 10 second, and 35 to 40 seconds is this one. Let's shade it differently. This is 35 to 40. So whenever you get enough uprising curve like this in a speed time graph or in a distance time graph, that uprising curve represents increasing speed or acceleration, right? So we can say between 0 to 10 second, object is speeding up. All right, or you can phrase it differently, the speed of the object is increasing or it is accelerating. All right, because the speed is not increasing uniformly, it is accelerating. So you can write all right. Now from 35 to 40 second, in the time interval 35 to 40 second, the speed of the object is decreasing. So I'll write here between 35 40 second, speed is decreasing. At that point, speed is decreasing. Or velocity is decreasing or it is decelerating. So if the speed is decreasing, it would be object would be decelerating. So you can write here object is decelerating. And what is the other difference between these two stages? Uh, one another difference is between 0 to 10 second in that stage. All right, in this stage the object starts from rest. All right, it starts from rest and then starts to speed up, hence it accelerates. However, at this stage the object was already speeding. Now it starts to slow down and eventually stops. How do we know that it eventually stops? Because after that we get a horizontal line, and horizontal line in distance time graph means the distance is now not being changed. And if distance is not being changed, that means the object is at rest. So we can write that difference as well. In 0 to 10 seconds, object starts from rest and in 35 to 40 seconds object comes to rest. Finally, mean at the end. Alright, let's move on to the next part. The maximum speed of the bus during these 60 seconds. Alright, this is what we need to find now, the maximum speed of the object during these 60 seconds. Okay, let's go back to the graph. You have to interpret the graph a little bit, and you need to figure out what's at what stage the speed of the graph would be maximum. All right, and for that you have to have the knowledge of gradient and the concept of gradient, that if you find the gradient of distance time graph, basically you get speed. And the gradient, in simple words, it represents the steepness. The more the steepness, the more the gradient. And now you, first of all, you simply try to figure out at what point the steepness of the graph is maximum. So I can say, like, from this point, in that interval between the point A and the point B, the steepness of the graph is maximum, right? The graph, the line is the steepest. So if we find the gradient of that line, we can find the maximum speed. So let me write down the points, the coordinates of the point A. That would be, if I zoom it in, it would be for point A 10, 11, 12, 13, like 13 against 100. This one can B can be 30 against 300. 30 against 300. All right, so basically the first value represents the value of x. Sorry, first value represents the value of x. The second value represents value of y, x1, y1. You can call this one x2, y2. Now let us apply the formula of gradient over here. All right, so we understand for maximum speed, we are applying the formula of gradient at the steepest portion of the graph, which is y2 minus y1, x2 minus x1. So y2 would be like 300 minus 100 divided by 30 minus 13. Then you hit it on the calculator. So it would be like 200 divided by 17, 11 point. We get something like, yeah, 11.7. On calculator we get 11.76, so you can write 11.8, 11.8 meter per second. Okay, so that would be the maximum speed. Now in the next part you need to find average speed of the bus before leaving the first bus stop and arriving at the second bus stop. For average speed we have the formula average speed equals total distance divided by total time. Total distance, let's see what the total distance is from the graph. It is, the total distance is 390. All right, you see this line represents 390. How do we know that? Because there are 10 lines between 300 and 400. So this one would be 310, 320, 330, 340, 50, 60, 370, 380, 390. So this one is 390, and divided by how much time he has taken throughout the journey before it comes to rest. Well, it stopped somewhere over here at 39 seconds. So 390 divided by 39. So you get like 90, yeah, 390 divided by 39. It would be straightforward. Uh, 39 tens are 390. So average speed you can write 10 meter per second. Then we have the next one, how this velocity differs from speed. So velocity is a vector quantity as it contains or as it requires direction. Okay, you can phrase it the way you want, or as it has a direction, or you can write it either way. Over to the next one, there are 3 periods during the 60-second where there is non-zero result for acting on the bus. Okay, 3 periods. Okay, complete complete the statements to indicate that these three periods and state the direction of resultant force in that period. First of all, let me go back to the graph. Graph has everything to do in this question. So if you take a look at this portion of the graph, the object was accelerating, and matter of fact, we were asked a question about the acceleration, and we answered that in the first like 10 second or 12 13 second, the sorry, 0 to 10 second, it was accelerating, and when the object is accelerating, the forces are unbalanced. Which force is greater? The forward force. So from 0, all right, between 0 and 10 second, the direction of the resultant force was forward. Why forwards or forward? That's not part of the question, why forward, but I'm just writing here anyway, forward, because as the object is accelerating, all right, the next one, uh between, all right, what is the next stage when the force is, when there is a resultant force? Well, if you go there, they have mentioned a period, right? They say between the period 21 to 24 second, object travels in a circular curve, in a circular path. Whenever an object travels in a circular path, there is always a resultant force that goes by the name centripetal force. So you can write what period was that, 21 to 24 second. 21 to 24 seconds, there would be a resultant force in what direction? You can say towards the center of the, let's say this is the center and the object is moving in the circular path. This is your object. What would be the direct, if the object is moving like straight over here, the direction of the direction of the resultant force would be perpendicular to the direction of motion, which would be basically towards the center of the track, or you can write perpendicular to the direction of motion. So this is kind of a generic answer. Whenever an object travels in a circular path, the direction of resultant force or the centripetal force is towards the center of the circle, or towards or perpendicular to the direction of motion. To direction of motion. And what is the third phase? The third phase, when the object is having a resultant force, non-zero resultant force at this stage, that one, because it was decelerating. And whenever an object is decelerating, there would be a resultant force, which would be the backward force, which would be directed backward. So it would be from 35 to 40 seconds, and you can write opposite to the direction of movement. All right, then we have the next one. During the journey, the air resistance acting on the value varies state by the air resistance change. We were discussing the same thing, that the speed of the object keeps changing in the journey. And if the speed is being changed, the air resistance would be changed accordingly. So you can write it in that way because the speed of the object varies. The air resistance also changes. Air resistance also changes. All right. So then we have the part 2 on figure 7.1. Mark can label with an M a time when the air resistance is a maximum value. So the point where air resistance is maximum. All right. So you have to find a point where air resistance is maximum. So basically air resistance would be, what's going on here is first, as the object was at rest, the air resistance keeps increasing, and at one stage it becomes equal to the driving force when the forces became balanced. So you can mark anywhere at this point where the forces are balanced, air resistance would have increased from 0 to the maximum point, let's say 30 newton, where it now balances the driving force. All right, and after that the driving force starts to decrease, and air resistance eventually decreases as well. So you can like mark over here. And how do we have to mark it? Is there special word? Mark and label with the nm. Okay, you can call that point, the black dot, as m. So this is a point where air resistance would be maximum. All right, once again, this is not a single point, a unique point. Basically you can mark anywhere between the range 10 to like 30 second. At this range you can mark the point m and anywhere at this range. All right, so that is from the 4 chapters. It was basically question from 4 different chapters, starting with mass, weight, density, turning effective force, kinematics and dynamics, the latest one obviously. And the next 2 questions I have chosen 15-mark question from pressure, and then another 15-mark question from elastic deformation. And the next 2 I'll be completing solving in my next video. So that's it for today. I'll see you in the next video. Take good care, everyone. Allah Hafiz.